Video 18 Multifunction Inverters. Grid connected systems with battery backup require multifunction inverters. That is, battery and grid compatible sine wave inverters. They are commonly referred to as multifunction or less commonly multi-mode inverters. Multifunction inverters contain features of grid connected and off-grid inverters. Like a grid-connected inverter, they contain anti-islanding protection. They automatically disconnect the inverter from the grid in case of loss of grid power, or low voltage, or low frequency, or over frequency. They also contain fault condition reset to power up an inverter when a problem with the utility grid is corrected. Like off-grid inverters, multifunction inverters contain battery chargers and high and low voltage disconnects. If you are installing an off-grid system, you may want to consider installing a multi-function inverter in case you decide to connect to the grid in the future. Even though multifunction inverters allow system flexibility, they are not always the most efficient inverters. That's because some portion of the electricity generated in such a system must be used to keep the batteries topped off. This may only require a few percent, but over time a few percent add up. In a system with poorly designed inverters or large backup battery banks, the electricity required to maintain the batteries can be quite substantial. It is also worth noting that as batteries age, they become less efficient and more power is consumed just to maintain the charge. This reduces the efficiency of the entire PV system. If you want the security of battery backup in a grid connected system, I suggest that you isolate and power only critical loads from the battery bank. This minimizes the size of your battery bank, reduces system losses, and reduces cost. Unless you suffer frequent and sustained utility outages, a batteryless grid-connected system usually makes more sense from both an economic and environmental perspective. Buying an inverter. Inverter comes in many shapes, sizes, and prices. Most homes and small businesses require inverters in the 2500 to 5500 watt range. Which inverter should you select? When purchasing an inverter through an installer, your choice may be limited. Most installers carry a line of inverters they are familiar with and have a high degree of confidence in. If this is the case, the installer will make a recommendation that fits your need from the inverter he or she carries. System voltage. When shopping for a battery-based inverter, you'll need to select one with an input and output voltage that corresponds with the input voltage of the battery bank in your system. System voltage refers to the voltage of the electricity produced by a renewable energy system. In PV systems, the arrays are wired to produce either 12, 24 or 48 volt electricity. Batteries are wired similarly. Because all components of an off-grid system, renewable energy system must operate at the same voltage, the inverter must match the source PV array and batteries if any. A 24 volt inverter won't work in a 48 volt system. If you are installing a 48 volt battery bank, you will need a 48 volt battery based inverter. Modified square wave versus sine wave. The next inverter selection criterion is the output waveform, basically the type of AC electricity they produce. PV array voltage, string size, and choosing the correct inverter. Today, systems based on 12-volt increments have largely fallen by the wayside. One reason for this is that most modern PV systems are batteryless grid-connected systems. Because there are no batteries, the inverters used in these systems can be designed to accept DC electricity from arrays at much higher voltages. In fact, most grid-connected inverters operate in an input range of 150 to 550 volts with a maximum of 600 volts. Higher voltage. Higher voltage reduces losses as electricity flows from the array to the inverter. Because less current flows at higher voltage system permit the use of smaller gauge conductors, which reduces installation costs. The higher voltage also allows smaller components in the inverters, reducing their size, weight, and cost. To accommodate the higher voltage inverters, manufacturers now produce PV modules with a higher nominal voltage 16, 24, 36. These modules are then wired in series to produce high voltage DC electricity for today's high voltage inverters. Battery based inverters are available in modified square wave and sine wave. Grid connected inverters are all sine wave, so their output matches utility power. Modified square wave electricity is a crude approximation of a grid power that works fairly well in many appliances and electrical devices in our homes and businesses. Although most office and household electronic equipment and appliances can function on modified square wave electricity, they all run less efficiently, producing less of what you want. That is, light, pumped water, etc. Waste heat for a given energy input. When operated on modified square wave electricity, microwaves oven cook slower. Equipments and appliances that run warmer might last fewer years on modified square wave electricity. Computers and other digital devices operate with more errors and crashes. Unless money is tight, I recommend sine wave battery based inverters for off-grid systems. Output power, surge capacity, and efficiency. When selecting an inverter for an off-grid system, be sure to pay attention to continuous output power, surge capacity, and efficiency. Continuous output power. Continuous output is a power an inverter can produce on a continuous basis. It is measured in watts, although some inverter spec sheets also list continuous output in amps. To determine the continuous output, you will need to add up the wattages of the common appliances you think will be operating at once. Be reasonable though. Typically, only 2 or 3 large loads operate simultaneously. Surge capacity. Electrical devices with motors such as vacuum cleaners, refrigerators, washing machines, and power tools require a surge of power to start up. It typically lasts only a fraction of a second. Even though the power surge is brief, if an inverter can't provide the power, the motor won't start. Moreover, the installed motor will draw excessive current and could overheat unless it is protected by a thermal cutout. When shopping for an inverter, Be sure to check out the surge capacity. All quality inverters are designed to permit a large surge of power over a short period, usually around 5 seconds. Surge power exceeds the continuous output and is listed on spec sheets in either watts or amps. Efficiency. Converting one form of energy to another results in a loss of energy. Efficiency is calculated by dividing the energy coming out by the energy going in. Fortunately, efficiency losses in inverters are quite low, usually only 5 to at the most 15%. It should be noted, however, that inverter efficiency varies with load. To get the most out of a PV array, most systems incorporate a function known as maximum power point tracking. The circuitry that allows MPPT is located in the inverter in grid-connected systems and in the charge controller of battery-based systems. Maximum power point tracking ensures that the array produces the most power it can during daylight hours. Noise and other considerations. Battery-based inverters are typically installed inside close to the batteries to reduce line loss. If you are planning to install an inverter inside your home or office, be sure to check out the noise it produces. Enquire about this upfront. Stackability. Finally, when buying a battery-based inverter, you may also want to select one that can be stacked, that is, connected to a second or third inverter of the same kind. Stacking permits homeowners to produce more electricity in case demand increases over time. Two inverters can be wired in parallel, for example, to produce the amp output of a battery-based PV system. Conclusion. A good inverter is key to the success of a solar energy system. So shop carefully, size it appropriately. Be sure to consider future electrical needs. But don't forget that you can trim electrical consumption by installing efficient electronic devices and appliances. Efficiency is always cheaper than adding more capacity. When shopping, select the features you want to buy, the best inverter you can afford. Although modified square wave inverters work for most applications, you will most likely be happier with a sine wave inverter. Here ends video 18, Multifunction Inverters. Thank you.